Hi everyone, so in this video we'll see the force of interest. In another word, it is the nominal annual interest rate compounded continuously or compounded infinity of times. Instead of compounded monthly, quarterly, here it is continuously compounded. So we know our formula, which is the effective interest rate is the 1 plus the annual nominal interest rate divided by the number of periods power the number of periods minus 1. Here, when we say it is force of interest or we say it is compounded continuously, we can write it like this. It is like this. So instead of this, we write it as lambda. So we can write this as this. So it is the effective interest rate here is 1 plus the force of interest lambda divided by m power m. M is still the number of period, which is infinity here. It is infinity here. Minus 1. We know that this is a famous limit, the limit of 1 plus x divided by n power n if n tend to the infinity is exponential of x. It is expo of x. So we can simply replace all of this by expo of lambda. Here lambda is lambda instead of x, here m instead of n, so we get this minus 1. So actually this is our formula when we have a force of interest or compounded continuously. And in another case, imagine you have the effective and you want to find the force of interest. We know this is from effective, we know that the effective equals expo lambda minus 1, which means expo lambda equals effective plus 1 here as written here, and we can apply the ln here. So ln of effective plus 1 equals ln of expo lambda, and we know this equals lambda. So lambda, which is the force of interest or the nominal interest compounded continuously, is the Neperian logarithm of the effective interest plus 1. Suppose you have lambda here. When you see this, it is same thing as lambda, or same thing as if I say it is a nominal interest rate compound continuously. If here lambda is 10% or 0.1, what is the effective interest rate? We apply our formula directly. So it is expo 0.1 minus 1, and we get 0.105, which is 10.5%. And in case we have the effective but we don't have the here, this one is the effective is 10%, but we don't have the nominal or the force of interest. Let's find the nominal here. So we use the second formula, which is the ln of the effective plus 1. So with the effective is 10%, and ln of 1.1 is actually 0. We get this 0.095 or 9.5%. This is the nominal interest rate compounded continuously. So to finish this video, let's check our formulas. So we have the first formula, the effective interest rate, how to convert from nominal to effective. So effective equals 1 plus the annual nominal divided by the number of periods power the number of periods m. So how many times it is, m here represents how many times it is compounded per year. So this is our formula to convert the nominal to effective. And to get the nominal from effective, it is the effective plus 1 power 1 over m minus 1 times m. And finally, how in case of continuously compounded, how to get the effective. It is actually the expo of lambda. Lambda represents a nominal interest rate compounded continuously, -1. And to get lambda, we can find it from this formula. It is the Neperian logarithm of 1 plus the effective interest rate. For the discount rate, it is the same principle. So what are the formula for the discount? So the effective discount rate is 1 minus the nominal discount rate compounded m times here, divided by the number of compounding period m power m. Now to convert from effective to nominal, we get dm equals 1 minus df, or d effective, power 1 over m, and everything times m. So to get the annual, if we divide this by m, we get the periodic. If it is 12, which means it is monthly. And finally, if the discount is compounded continuously, the effective will be 1 minus expo minus lambda, and lambda will be minus ln of 1 minus the discount, or the effective discount. And finally, we have this relationship between the effective discount and the effective interest rates. We talked about this in the discount video. So the effective discount is the effective interest over 1 plus the effective interest, and the effective interest equals the effective discount divided by 1 minus the effective discount. So this is all about how to convert from effective to nominal and nominal to effective. Now in the next video, we will see a new chapter, and it will be about the annuities. So thank you for watching, and see you in the next video.